Packet tracer. Compare command line interface and software-defined networking controller network management. The addressing table. All subnet masks are 24. 255, 255, 255, 0. 3 routers. 3 routers. And switches. Okay, the switches. And devices like PCs and the server, the example server. This server. In this packet tracer activity, you will compare the differences between managing a network from the command line interface and using a software-defined networking controller to manage the network. Explore the network topology. You will become familiar with the topology. You will use the network programmability activities. Review network configuration documentation. The network is configured as follows. Routers are using OSPF version 2. SSH is enabled on all devices with user Cisco and password Cisco123 and exclamation mark. R1 has no hosts. Okay, R1 has a server on local area network. The server and R2 LAN IPv4 is statically configured. This is the local area network of R2. Okay, R3 is the DHCP server for LAN 1 and LAN 2. Okay, R3 is the DHCP server for LAN 1 is this and LAN 2 this another. Switches are layer 2, no VLANs. Okay, these switches, layer 2 switches, then these another switches, layer 2 switches. All SWR switches belong to LAN 1. Okay, these 4 switches belongs to LAN 1. Okay, the network, as you can see, is 10.0.1. 10.0.1, 10.0.1, 10.0.1. Verify that all devices can ping each other. Either use the command line on each device. Okay, for example, go to PC4, this PC, command prompt, verify the IP configuration, ipconfig, its IP address is 102.3 and the default gateway 102.1. And ping the server. The IP address of the server is this 101.100. Okay, ping the server. Ping 192.168.101.100. Very good. And ping this another device, admin PC. This is the IP address, as you can verify here. DHCP configuration 139. Okay, but be careful. 10.0.1 129. From PC4 ping to 10.0.1 129. Very good. Next, 130, the PC1. Very nice. 10.0.2 139. 10.02.129. Ping to PC number 2. Success to 130. 10.02.130. Very good. Okay, all is verified. Use the command line interface to gather information. You manually access each device to gather information about the software version. From the admin PC, securely access to the SWR3 switch. Okay, from this PC, admin PC, access to this switch, SWR3. Okay, and use the command prompt. Okay, go to admin PC, go to desktop, close this, desktop and command prompt. And enter the command SSH-L, is not 1, is L. Cisco is the username, and finally the IP address of the device. The IP address is 10.0.1.4. The IP address of SWR3 is 10.0.1.4. Okay, the L option is letter L, not the number 1. Okay, and SSH protocol option L, Cisco. Cisco is the username. Remember, SSH is enabled on all devices with user Cisco and password Cisco123 exclamation mark. Okay, user is Cisco. The IP address of the device 10.0.1.4. Enter. And the password Cisco123 exclamation mark. Cisco123 exclamation mark. Enter. Very good. SSH connection to switch, and the password. You are now logged into SWR3. Gather information about the software on SWR3. Enter the following command to filter the output of the show version command to build just the release software installed on the device. Notice that the SWR3 is running iOS 16.3.2 and bootloader 4.2.6. Okay, this command show version pipe. Okay, and include the line release. Case sensitive, uppercase. Okay, I will extend this to view. Okay, enter. And you can see the iOS software for Catalyst Layer 3 switch. The version is 16.3.2. And the bootloader is version 4.26. Copy the information to your clipboard. Open a text file editor and paste the information into a text file. Okay, and copy this. Open a notepad on Windows operating system of your choice. Paste. Save the file as software versions. File, save. Software dash versions that txt. Okay, save. and hide. Gather the software information for the rest of the network devices. From the command prompt on SWR3, securely access another network device. Continue documenting the software versions until you have completed all 9 network devices: SWL1, SWL2, SWR1, 2, 3, 4, R1, R2, and R3. Okay, 9 devices. 1, 2, 3, 4, 5, 6, 7, 8, 9. I have one, but I need the information of 8 devices. Okay. Go to admin PC again. I am connected to switch SWR3. You can connect another device from this switch. So access SWR4. The IP is 10.0.1.5. SSH option L. The user is Cisco. The IP address 10.0.1.5. Okay, be careful, 10.0.1.5. And the password, remember, Cisco 123 exclamation mark. Cisco 123 exclamation mark. Okay, I am on SWR4. And copy this command, show version pipe include release, enter. Copy the output. Also include the name of the device, is SWR4. Include the name. Okay, enter, paste, enter. Okay, SWR3, the output, SWR4. Okay, the output. The output includes the software version. Okay, and now go to SWR1 10.0.1.2 from admin. Okay, SSH Cisco 10.0.1.2 is this 10.0.1.2. Password Cisco 123 exclamation mark, enter. SWR1 and copy this command. Copy this to the notepad. Okay, and the next device 10.0.1.3 SSH option L Cisco 10.0.1.3. Password Cisco 123 exclamation mark. SWR2. Copy this command. Enter. Copy this to notepad. Enter. Now the next device is R3. Choose this IP or this another. I prefer this 10.0.1.1 is the IP on the same network 10.0.1.1. Okay, and go to admin PC. SSH option L Cisco is the user, 10011. Password Cisco123 exclamation mark. Okay, R3, the router, and copy this command, enter. Copy. The software is iOS version 15.5. Okay, copy this. Enter. Now access R1. Use this IP 192.168.1.2. SSH option L Cisco 192.168.1.2. Enter. Password R1. Copy this command. Copy this. Enter. Now access this IP of R2 192.168.2.2. SSH option L Cisco 192.168.2.2. Okay, point. Enter. Password. Okay, R2 show version include release. Copy this. Enter. Now access this switch SWL1. The IP address is 192.168.1.1.2. 192.168.1.1.2. Okay, go to the admin PC and SSH option L, the username, and 192.168.1.1.2. Enter. Password SWL1. Copy this. Enter. Copy the output. Enter. And finally, this device SWL2 1022. Okay. SSH option L Cisco 192.168.1.022. Be careful, 192.168.1.022. 192.168.1.022. Enter. Password. Okay. SWL2. Copy this line. Paste. Enter. Okay. Copy this. Enter. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 devices, the information of 9 devices. Okay, save this file. Exit out of all of your SSH sessions. Okay, so you are on switch SWL2, so exit, exit, SWL1, exit, R2, exit, R1, exit, R3, exit, SWR2, exit, SWR1, exit, 4, exit, 3, exit. Now, this is the PC prompt. Very nice. And configure the PD controller. For many years, network administrators have used early automation tools such as bash scripts or SNMP-enabled software to complete a process similar to what you did in the previous step. However, with the introduction of software-defined network (SDN), this process has been greatly enhanced. Packet Tracer provides a simple PD controller to simulate an SDN controller. In this part, you will connect and configure the PD controller or Packet Tracer controller. To learn more about Packet Tracer's implementation of the network controller, click the Help menu, then Contents. Okay, to learn more about, go to Help and Contents. In the index on the left, about midway down, you will find the hidden configuring devices. Configuring devices. Underneath this heading, find network controllers. Okay. Here, network controllers. Click here. Here you will find a wealth information, much of which you will explore in the activities in this course. Okay, you can see how to find the network controller on end devices. On a basic level, you can configure a global settings and interface settings of a network controller just like you can do on a regular PC. In addition, the controllers can be accessed from outside Packet Tracer via HTTP REST APIs. Okay, the connection, configure on web browser, use the web interface, and create an account. And you will see the dashboard. Okay, very good. Topology in the navigation bar will show all managed devices and their connections. Okay, very nice. Add a network controller to the topology. Okay, end devices, network controller. Okay, go to end devices, down here, end devices. Network controller is this. Okay, this. And place. Very good. Add the network controller in the blank spot left on the SWL1 switch. Okay, place here close to SW1 switch. This is the switch. Place the controller here. The name should already be PD controller 0. If not, click the name and change it. Okay, PD-controller 0. Very nice. Connections and copper straight through cable. Okay, connections and copper straight through this down here, and click the controller and choose gigabit Ethernet 0, and then click switch SW1 and choose the first available gigabit Ethernet interface. Okay, click the copper straight through cable, click the controller, gigabit Ethernet 0, gigabit Ethernet 0, click, okay, and click on the SWL1 switch, and click the first available gigabit interface is gigabit Ethernet 102. Gigabit Ethernet 102. Very nice. Configure connectivity for the PD controller 0. Go to config, okay, click on the controller, go to config. Okay, enter 192.168.1.1 as the gateway address. Okay, the default gateway for the controller is this, 192.168.1.1, the LAN interface or router 1. 192.168.1.1. Okay, and on the left, under interface, click gigabit Ethernet 0. Click here on interface gigabit Ethernet 0. IP address 192.168.1.1.254. IP4 address 192.168.1.1.254. Subnet mask 24. 255, 255, 255.0. Very good. On the real world, click controller. Okay, on real world section, click controller. If the server status is stop, move on to the next sub-step. If the server status is disabled in preferences, then you will need to enable external access by following these instructions. Okay, go to options, preferences. Okay, verify on preferences. Miscellaneous. Under external network access, enable external access for network controllers REST API. Be sure enable external access for the network controllers REST API is enabled. Okay, verify is enabled. Okay. Close preferences. go to controller config, real world controller. The server status should now be stop. Okay, stop. Access enable to enable it. Okay, enable here. Server status changes to listening on port 58,000. Server status listening on port 58,000. If the port is some other value, change it to 58,000. Okay, this value should be 58,000. This is the port number in the Python scripts. From admin, verify connectivity to the controller. Verify that admin can ping the controller. If you are not able to ping, make sure your configuration matches the specifications in the previous step. Okay, and remember the IP address of the controller is this on config, and gigabit 0 is this 192.168.101.254. Go to admin, this PC, command prompt, and ping the controller. Ping. Remember, you are on PC prompt. Ping 192.168.101.254. Very nice. Register a new user and log into the controller. Go admin desktop web browser. You can do this from any PC. I will use the admin PC. Close the command prompt, go to web browser. Enter the IPv4 address 192.168.101.254. Remember the address of the controller 192.168.101.254. Go. And create a username and password. Cisco the username, Cisco, and password Cisco123 exclamation mark. Cisco123 exclamation mark. Confirm the password Cisco123 exclamation mark. Okay, and click on setup. Now login. Username Cisco, password Cisco123 exclamation mark, and login. Now you can see the dashboard. Okay, very nice. You can use whatever username and password you want here. You are now logged into the dashboard for the controller. It may be helpful to expand the window so you can see the entire interface. Okay, very nice. Use an SDN controller to discover a topology. You will configure the controller to use Cisco Discovery Protocol, CDP, to automatically discover the 9 network devices in your topology. The controller will also discover all 5 host devices attached to the network. add credentials to access all the network devices in the topology. From the Network Controller graphical user interface, click the menu button on the left of the Cisco logo. Okay, this menu. Okay, again, provisioning. From here, you can manually add networking devices. However, you will use CDP to automatically discover devices for you. Okay, click on provisioning, credentials, plus credentials, new credential. Go to credentials tab, plus credential, new credential. Okay, and for username enter Cisco, and for password Cisco123 exclamation mark. Leave enable password blank. For description enter admin credentials and click OK. Okay, username is Cisco, password Cisco123 exclamation mark. Remember the username on networking devices and password on networking devices. Enable password, leave blank, and description use something admin credentials. Choose any description, admin credentials, then click on OK. The new command line interface credentials are now stored on the controller for use in automation tasks. Okay, this is the new. Use CDP to discover all the devices on the network. Discovery plus discovery, new discovery. Discovery tab plus discovery, new discovery. For name, enter SWL1, the IP address 192.168.1.12. Okay, remember this device, SWL1, IP address 192.168.1.12. Okay, and name SWL1, IP address 192.168.1.12. 192.168.1.12. For command line interface credential list, drop down the list and choose Cisco admin credentials. Okay, at the end, choose the only one option, Cisco admin credentials. The credentials previously created. Okay, add. May take a while. You should now see the status as in progress. You can wait for Packet Tracer to finish simulating this process, or you can fast forward time button on the main topology window to speed up the process. Okay, wait or click here fast forward time if you want. I will wait. Okay, it's ready. Use an SDN controller to gather information. You will use the controller graphical user interface to view information about the network devices and host devices in the topology. You will view the topology created by the controller and then conduct a path trace across the network. View the list of network devices discovered. Click Network Device. You should now see all 9 network devices listed. Okay, go to Network Device and CDP, Cisco Discovery Protocol, discovered the 9 devices. 1, 2, 3, 4, 5, 6, 7, 8, 9 devices. Click the gear icon next to any device's hostname to see the information collected by the discover process. Notice that the software version is listed as well as a variety of other detailed information about the device. Okay, for example, on switch SWR1, click here. You can see the details, hostname, the software, 1632. The number of interfaces. Okay, very nice. Cancel. Router R1, the version 15.4. Very nice. The number of interfaces. View a list of all of the host devices discovered. Return to the dashboard. Return to dashboard. Click the menu next to the Cisco logo. On the dashboard, you will see the charts with the number of hosts that can be reached via ping and the number of network devices that are managed, but should be 100%. Okay, the charts. %, 100%. Percentage of hosts that can be reached via ping. Percentage of network devices that are in managed state. Okay, 9 devices, 6 hosts. Okay, this is the controller. The hosts, the number of hosts are 1, 2, 3, 4, 5, 6. 6 hosts. And network devices 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 devices. You should also see tiles for quality of service, network device, and hosts. Click the gear icon for hosts. This will take you to the hosts tab for assurance. Okay, look at here on hosts. Click here on the gear. 6 hosts. IP addresses, MAC addresses, IP addresses. On this page, you will view all the layer 2 and layer 3 connectivity information for each host, as well as the network device to which each is attached. Okay, MAC address is layer 2 information, IP address is layer 3 information, and connected network device. So, for example server is connected to the SWL1 on gigabit 103. Okay, example server is connected to SWL1 connected on gigabit 103. Okay, Admin PC is connected to SWR3 on gigabit 1021. Admin PC is connected to SWR3 on gigabit 1021. Click the gear icon next to any host. Okay, for example, the admin PC, the gear. Now you can see connected to interface, connected to the device, the IP address of the connected device, the local IP, the MAC address, the host name. Cancel. View the topology created by the controller. Click topology. Notice that the controller dynamically created the same topology you see in Packet Tracer's main window. Okay, go to topology. Now you can see the topology. Very good. You can click any network device to see its details. For example, R3 click. Now you can see the details. You can also click and drag the device icons to rearrange the topology. However, your changes will not be saved when you leave the topology workspace. Okay, you can drag the device. Okay. Trace the path from one device to another. Click Path Trace tab. Okay, click here Path Trace. Plus path, new path, plus path, new path. Trace the path from one end of the network to the other. For example, you could enter the IP address for PC1 to PC4. Then click OK. Okay, the source can be, for example, PC1 10.01 130. 10.01 130. And PC4 192.168 102.3. 192.168 102.3. Okay. Click the new path that was added. Okay, click here. Condition completed. Okay, this is the path. You will get a route report that shows all the hops from source to destination. Notice that only layer 3 device information is listed. The switches are shown as unknown device. This is because they are all operating at layer 2 only. Okay, PC1, unknown device, R3, R2, unknown device, PC4. Okay, PC1, unknown device, R3, R2, unknown device, PC4. Very good. Use an SDN controller to configure network settings. A major benefit of network automation using a controller is the ability to configure global network settings and policies for all devices and then push that configuration with the click of a button. In this part, you will configure the controller with network settings for DNS, NTP, and syslog. You will then push this configuration to supported network devices. Finally, you will verify and test the policy. investigate the configuration of the example server. Go to example server, go to services, example server, click, go to services, DNS, DNS, DNS. Notice that the DNS service is enabled and that there is one record for www.example.com. Okay, DNS service enabled, one record www.example.com for 192.168.1.1.100. Okay, under services, syslog. Notice that the syslog service is enabled. Syslog service enabled. Okay, some logs. Services MTP. NTP is enabled. NTP enabled. Configure a global policy for DNS, syslog, and NTP. Click on admin. Okay, the admin. If you closed admin, you will need to open the web browser and re-authenticate with the controller. Okay, login. Click the menu, policy. Okay, menu, policy. Quality of service tab. Notice there are options for configuring the scope and policy. You will configure network settings. Okay, to configure scope and configure policy. Click network settings. Click network settings. DNS, enter example.com as the domain name. Okay, click DNS. Domain name will be example.com. And this IP 192.168.1.1.100 is the IP address. Okay, this is the DNS server. Okay, so the DNS server will be the example server 192.168.1.1.100. Okay, this is the domain for the devices, and this will be the IP address for the DNS 192.168.1.1.100. Okay, and save. Save it successfully. On NTP, also the IP address and save. Example server is also the NTP server. Okay, go to NTP 192.168.1.1.100 and save. Save it successfully. Syslog, the same IP. Save. Syslog 192.168.1.1.100 and save successfully. Click DNS, NTP, and syslog again to verify the information is correct. If not, correct the information, saving each time. Okay, go to DNS, very good. NTP, very good. Syslog, very good. Click Push Config. The push all network settings. Verify your settings and click OK. Okay, push config. Okay, push all network settings. Okay. Save it successfully. Verify and test the network settings that were pushed to the devices. At the bottom of the network settings window, there is the following. This functionality is only supported on the devices running iOS XE operating system and switch 2960-24TT. This means that for this version of Packet Tracer, your global settings were only applied to the routers. Okay, now this functionality is only supported on devices running iOS XE operating system and switch 2960-24TT. Click on any of the three routers, R1 for example, command line interface. Okay, click on R1, command line interface tab, enter. You will see the prompt. Enter the privilege exec mode and verify the DNS settings. Enable to go to privilege exec mode. Enter. Once you are on privilege exec mode, use this command: show run pipe begin IP domain. Enter. You will see the domain name example.com and the server IP address, the DNS server IP address. Enter the following commands to verify NTP settings. The time on R1 should match your current time. Packet Tracer may take a little time to propagate NTP messages. Okay, show NTP associations. Space. Show NTP associations. Enter. And you will verify that R1 is associated with example server 192.168.1.100. Okay, is associated with that server. Show clock on R1. Show clock. Okay, the date and time. Okay, verify on the server. Go to example server. Verify date and time. And it's the same. Okay, date and time, the same. Okay, and enter the following command to verify login is configured. Show run include login. Show run pipe include login. Okay, enter. Now you can see the syslog server is this IP 192.168.1.100. To test login, shut down the serial 010 interface and then reactivate it. Okay, on R1, configure terminal to access global configuration mode. Configure terminal. Okay, I am on global configuration mode and access the interface serial 010. Okay, on R1, this interface serial 010. Interface serial 010. Enter. Shut down. Then re-enable with no shutdown. Okay, shut down. Enter. Okay, now it's red because the interface is disabled. Shut down. Re-enable and with no shutdown. Enter. Okay, now it's green. Okay, and to exit enter end to exit the interface configuration mode, and now you are on privileged access mode. Finally, go to example server services syslog. You should see the same syslog messages you saw in the command line interface are also logged to the server. Double click any of the entries to review the messages. Okay, go to example server, go to syslog. Okay, on services, go to syslog, and now you can see the messages, and now you can see the messages from at the end from you can see the syslog messages at the end from 192.168.101. This IP that is connected close to the example server, 192.168.101, 192.168.101, interface serial 010, click, double click and change state to administratively down, line protocol down, double click to view all the message, OSPF process down, then serial 010, change it state to up, line protocol up, and this is an OSPF message configured by console. Okay, very nice. And now you can see how to manage the network from the controller. Okay, very nice. Thank you very much.